Welcome to week 2 of Introduction to Python. For today's lesson, we're going to go over a couple things, including statements, commenting, operators, and we're going to go over if statements and their varieties. At the end, we'll go over some examples. So what are Python statements? A Python statement is a single line of code. It's basically a command. For example, in the little code box below, we can see that string 1 is equal to hello. By assigning the string of hello to the variable of string 1, we run one command, making this a single Python statement. On line 3, we can see that the statement is print string 1. The command is printing string 1, so in this program, we have 2 lines and 2 statements. But what if we want to take one statement and put it across multiple lines? Or what if we want to take multiple statements and put them all on one line to save space? Well, let's look at these. If we want to take one statement and put it on multiple lines, we can use the line continuation character for multi-line commands. So what's an example where the line continuation character and multi-line statements are useful? Well, let's say we want to assign x not to a direct value, but to 1 plus 2 plus 3 plus 4 plus 5. In a normal line, this might look a little bit long, but we can use the multi-line and continuation character to make sure that we can see the full code, aka spread this one statement across multiple lines. So we can turn x into 1 plus 2 plus, and then we can add the continuation character to let Python know that the next line is still part of the statement, and then 3, 4, and then do the same for 5. At the end, we can use our second statement to print x. But what if we have a bunch of quickly written code that we want to combine into one line? This isn't typically recommended for more than just assigning variables, but for this we can use the line combination character, aka the semicolon. So let's say we want to assign 3 variables, x, y, and z. We can use the semicolon to differentiate between the statements of x equals 1, y equals 2, and z equals 3. At the end, our second statement, or actually technically, our fourth statement can print x, y, and z. So sometimes in Python, the code will get a little bit complicated, or it will take a second for the reader or the writer of the code to identify and understand the code. Sometimes for this, we need to add English words so that our brains can understand, or just to tell ourselves, hey, this is what this line of code means. So what we can do is we can add these things called comments. They help the reader quickly understand the code. Now note that comments don't change the actual program. We could add a ton of comments everywhere and it still wouldn't change the actual value or result of the program. But for Python to know that this line is a comment and not an actual command, we add a hashtag or the pound symbol in front. As shown in the little clipit, we have x equals 3, and then we can add the comment using the hashtag symbol of this is a comment. For this part, we're going to go a little bit deeper into operators. Let's look at the AND operator. Now, AND, OR, and NOT are all these things called logical operators. Logical operators typically rely on logic, as the name suggests. The AND basically makes sure that both conditions are true. So what does this mean? Let's take an example. It is raining and I have an umbrella. Let's say it is actually raining and I do have an umbrella on me. Then the value of it is raining would be true because it is actually raining. The value of I have an umbrella would also be true because I do have an umbrella. So the value of it is raining and I have an umbrella, since both values are true, would be true. But what if it is raining and I don't have an umbrella? It is raining would be true because it is raining and I know it is, but I have an umbrella would be false because I don't have an umbrella. We could simplify this expression into true and false. What is true and false equal? Well, and makes sure this value and this expression is only true if both the values are true. Since I have an umbrella is false and the expression is true and false, one of the two conditions is false, making the entire expression false. Therefore, true and false is false because one of the values is not true. true and true is true because both values are true. False and false is still false because there's nothing that is true, making that false. We can think about and as making sure that two operations both are included. Since true, nope, just cut that part out, future melody. Now what if we want a different value for these expressions? Well, we have the or operation. Let's use the same example. It is raining or I have an umbrella. Now, the word or in this context states that either or is true. If either one of these is true, then the entire expression is true. So, if it is raining and I don't have an umbrella, again, it would be true or false because it is true that it is raining and it is false that I do have an umbrella. So, the value of this expression would be true or false. The thing with or is that since one of these two is true, then the entire value of the expression is true. Unlike and, which requires both values to be true, or only needs one of the two values to be true. Similarly, true or true is true because at least one of these values is true. False or false is still false because both values are false and neither is true. Therefore, the main difference between or and is that or only requires one of the values to be true for the entire expression to be true, while and requires both of the conditions to be true in order for the expression to be true. Let's look at the final main logical operator, not. So the idea of not is that it returns whatever the expression is, well, not. So let's say the value of raining, the variable, is false. The value of the variable is false, so the expression is not false. Well, what's not false? Since operators can only have two values, true or false, and this is really important, not whatever the expression is will return the opposite of the expression. Since raining is false, not false is equal to true. Similarly, if it was raining, not true is equal to false. So what can we do with these logical operators? Well, one thing to note is we should probably memorize these, so take a second to pause the video and just kind of absorb this chart. The idea is A and B are two different values that can either be true or false. These are Boolean variables. A and B corresponds again with the same rules of and, that it is only true if both A and B are true. A or B is only true if at least one of A or B is true. And not A or not B would be the opposite of the value of A or B. Notice that these logical operators can be combined. For example, I can say not A or B, but I would require parentheses for most part to see if I would do not first or first. So let's say A and B are false and false. A or B would be false, as we can see from this chart. However, not A or B would be not false, making it true. The next type of operator we have is called the relational operator. The idea of this is that it is performed usually on two numbers, but occasionally on strings, as we will mention near the end of the class. So relational operators work pretty much the same way they do in math. We have less than, equal to, less than or equal to, greater than or equal to, and not equal to. Now these operators can only return a true or false value. One common mistake that is made is the equal equals. So Python has a single equal sign and a double equal sign, and they both mean very different things. A single equal sign is only shown for assignment. As we can see in the right-hand side, let's say I have a variable a, and we're assigning the value of 2 to a. The single equal sign shows that we are assigning the value. However, the double equal sign is showing that we are comparing the values. Let's look at the if statement. If a single equal sign is equal to 1. This part isn't right because in order to compare the values, we would need to use two equal signs. In Python, this specific piece of code would run an error because we can't use if a equals 1 because we're just assigning 1 to a. Now let's look at some basic examples of relational operators. Feel free to pause the video as you go along to try and answer the questions. Our first question is 10 greater than 4. Remember that we can only have true or false values. This would be true because 10 is indeed greater than 4. What about this question? 2 is greater than equal to 2. Is this true? The answer to this is yes, it is true, because 2 is not greater than 2, but 2 is equal to 2. 2 is greater than equal to 2. What about this one? One thing to note is that we can compare integers and floats, meaning that this would run in Python, but it would still return false because, of course, 4 is not equal to 4.2. Final example, what about this one? The explanation for this is that 5 is not equal to 2, meaning that this value is true. Finally, let's look at if statements. What is an if statement? An if statement is a part of Python that basically takes a condition, as we can see on the right-hand side, if something happens, and will only execute a certain block of code if that condition is true. So if something happens, then it will do this. The condition is where operators are important. If the operator returns true, aka if something happens is true, then it will execute the code. Otherwise, it won't. Python has a certain idea of indentation here, and indentation is really important, especially for if statements. If we want to print other code outside of the if statement, even after the if statement is finished, for example, if this statement is false and it doesn't go into the if statement, and we still want to print stuff out, then we would make sure that the code is unindented. So indentation shows which values should be only executed or which blocks of code should only be executed if the if statement condition is true. Python will run an error if nothing is inside the if statement, so make sure at least one line is indented and try not to randomly indent lines when you code. Other languages will sometimes use curly brackets or other methods to see what is inside the loops or the if statements. What if we want to execute a certain piece of code if something does not happen? Well, the else in the if-else statement only executes a blocks of code when the condition is not true. We need to realize that else does not work by itself. It only works after an if statement. So the if-else statement is a type of if statement. If something happens, then again we would do this. However, if that same condition is not true, in every other circumstance we would do this other block of code, and that's the purpose of the else. What if we want to have multiple different types of conditions? Well, then we can do these things called nested if statements and elifs. So if a certain condition happens, then we would do this. Elif, which is basically literally mushing up the words else and if. Something else happens, we would do this. And then again, else, if neither of these conditions was correct, then we would do this. If the first condition of if is correct, then we won't look at else or elif. However, if the first condition is wrong, then we will execute and look for elif. Only if both the conditions from if and elif are wrong and false, then else will execute. Notice that else and if is the same as elif, since elif is pretty much just trying to put the code together so it's faster. So if we were to execute if something, aka the if condition, else, then look at the next if, which is called a nested if statement, it's exactly the same as writing if something happens, elif something happens, because in both cases we will only look at the second if, or the elif, only if the first statement is false. In both statements, we have the else being and catching any other circumstance. Let's look at some examples of if statements. X is equal to 3. If x is greater than 3, print x is greater than 3. Elif x is equal to 3, print x is equal to 3. Finally, else, print x is less than 3. So in this case, which block of code do you think would execute? Well, let's look from the top. If x is greater than 3. Well, x is 3, and 3 is not greater than 3, so the first if statement would not execute. Then we would go to the elif. Elif x is equal to 3. Well, 3 is equal to 3, so we would run this piece of code. Print x is equal to 3. So in the output, we would print x is equal to 3. Since elif was true, and one of the conditions was true, we wouldn't execute anything else, and the program would be over. Now let's change the value of x. What if x was 4? Well, let's go through the program again. If x is greater than 3. 4 is indeed greater than 3, so we would print x is greater than 3. Since the if was since the if condition was true, we wouldn't look at the elif or else, and the program would simply stop here. Finally, let's change the value of x to 1. Again, let's run through the program. If x is greater than 3. 1 is less than 3, so this is false. Elif x is equal to 3. Well, 1 is not equal to 3, so this is also false. Finally, we would go into the else, and we would print x is less than 3. Here, the program ends. Now let's look at some ending examples and problems. If we combine logical operators with if statements, what would this program print? Feel free to pause the video and try and figure it out. Or you could try and run this on your own Python terminal. Well, let's look at the program. X is true, y is false. So our first condition is if x and y. If you recall, and is only true if both x and y are true. In this case, y is false, meaning that the condition is false. So we would go to else and print no. What about this one? Well, it's interesting to note that a lot of these examples can actually be used in, say, real life. So this is where Python can actually help your life or your decisions. So hiking is false and running is true. The first if condition is if hiking and running. Again, and is only true if both hiking and running is true. And since hiking is false, this statement is false. So now we go to elif. Elif hiking or running. If you recall, or only returns true if at least one of the values is true. Since running is true, we can see that this elif statement is true, so we would print just a bit. Finally, let's look at this example. Be sure to break it down when you look at it. Well, let's see. Today is equal to Tuesday, the string. Raining is true. So our first if statement asks is if today is equal to Monday. Note that some operations can be used on strings. For example, we can use the equal. Since Tuesday the string is not equal to Monday the string, this if condition is false. So then we move to elif today is Tuesday. Since today is equal to Tuesday the string, and these two values are equal, we would go into the elif. Make sure that when you run if elif and you try and use the equal sign, that the indentation and the capitalization of, say, strings are exactly the same. So if this was a lowercase Tuesday, these two values would not be the same. So let's look. If raining is equal to true, well, raining is true, so we would execute this other if statement. In this case, we would print ping pong, and then the code would be over. Try running these programs on your own devices afterwards. Thank you for watching this episode of, did I just say episode? Thank you for watching this week's lesson, and hope to see you next week.